weights are these regression paths. You want to know, are the outcome means different? The structural means. And then the covariances. Sometimes we don't really care whether the correlation is the same between two groups or not, but it's a way that they can differ. Where is that? Structural residuals. That's this error thing out here. And then finally the measurement residuals. That's going to be the de facto difference. But, well, as I'll get to on the next slide here. Oh wait. I really thought I had. Sorry. And now I forgot what I was going to say. De facto is what I was going to say. Anyway, questions? Yes?
What about if you have multiple groups?
Great question. Everything that I'm going to show you, the same process plays out over multiple groups, but the pain in the ass factor goes way up. Mm-hmm. Because in essence, multi-group analysis works like a t-test. And so you have to kind of decide how you're going to compare groups. You can test to see if A is different than B, if A is different than C, if C is different than B. And if C and B aren't different, then you can test to see if A is different than the combination of B and C. So it's very clunky beyond two groups, but the logic and the procedure is exactly the same. It's just extrapolated out. I'm going to show you how to do this next, and you'll see that you could just have another chunk there. I'm limiting what I'm talking about in class to two groups, just because I don't need to take you guys through that other procedure, because it's all the same. It's just it would take a lot more of your time.
Tim?
Yes?
So this is wildly different from the way that we've thought about two-group things, and just tell us what the problem is, because this is really, really very attractive. So like our approach has been like, come up with the best model we can, and then do a two-group model, sort of constraining everything to be equal, everything not being structural means and that sort of thing. And kind of with the idea that that's sort of an omnibus test that's gonna, clear out sort of some experiment-wise error, and it's gonna tell us like, really are these different? And then if so, where? And so it's really a top-down as opposed to, well, I don't know,
that
step-by-step, which really makes a lot more sense.
So this is a great question, and to some extent it shows the challenges with SEM in general, because just for the sake of argument here, you can say, I'm going to constrain structural weights. I'm going to constrain both of these paths. But let's say you had 5 variables in here, okay? I'm going to constrain all 5 of those paths and test to see, do the structural weights differ? What that means is that's going to be a 5-degree of freedom test. Mm-hmm. And in that way, it's kind of like an omnibus test. Are there differences in here? However, that is fine. That is justifiable. However, that may not actually get at your research question. It may be that those other 4 things, those are just covariance. And your real research question is, does this path differ? So what you do is you constrain those other 4 paths, and then you do a 1-degree of freedom test on that path, constraining that one path to be the same. So that is also a good approach and can sometimes zero in on your question more. But you can also do it kind of like this global, are there differences here? But as you know, the threshold to cross for a 5 degree of freedom change test is a lot higher than a 1 degree of freedom test. And it could be that there are differences in the covariance, but you don't care. And so then you really want to know, is the difference here? And so that's a reason to do it in a smaller steps sort of way. But that is, I was trying to allude to that idea with, you in general go through those 8 things. Well, not necessarily all 8, but that's the list of the things. But each one of those can have a series of sub-steps. And the structural paths portion in particular, structural weights. That one in particular may be the one that you want to drill down into, and there might be 8 steps that go into just testing structural weights, because you want to know, well, what about this path? What about this other path? What about these 3 paths? I mean, whatever it is. So it's not necessarily that this is done in one big thing. Yes?
So can you go from fully constrained to unconstrained working through the steps, or you always want to go from fully unconstrained working to the constraints?
I see. So can you start with everything constrained to be the same and free one path?
Yes.
Can you? Yes.
Okay.
Is it bad? Not necessarily.
I mean, just to
But
clarify, these are situations where we don't have a priori hypotheses. We just want to say, look, we don't really think it's going to vary by race, but let's just find out.
Right.
Does it just
But you can imagine the advantage, if you think about building up versus working back, the advantage of letting them be different is that you aren't making assumptions. So, for example, if you think about that measurement model, you might be testing, does the structural path differ? But if you haven't tested if the measurement model is different, then I'm not sure how good of a conclusion it is about that structural path. Because it could be that the structural path is only different because the measurement is actually different, but you're not letting it be different. In other words, it's kind of a more important question to know, does this differ? And therefore,
does all the rest make sense?
yeah. But, June, I have done what you were talking about, where in essence they are the same, and I'm just saying, well, if I let them be different here, is that any better? So I've done what you're talking about, and it is also justifiable. But this is probably more consistent with, let's say, best practice, or most accepted practice. It's worth noting that your model doesn't necessarily have all of those things in it. If you don't have a latent variable, you're not going to have any of that measurement model stuff. And so you just move on. So it's only with respect to what you have in your model. I remember what I thought was in my slideshow actually isn't there, and that's because it's in a Word document that you should download from Blackboard. In the folder called Multi-Group Models. There is an instruction sheet on how to run multi-group models in Onyx. And I'm just going to show you one thing at the bottom. So this is entirely consistent with what I had on that slide. But notice at the bottom here, oftentimes people talk about weak invariance, strong, oh wait, weak, strong, and strong. Weak, strong, and
Very strong.
very strong. Strict. Weak, strict, strong, and strict. That's. Look up that article, and you tell me what it says.
Isn't it configure?
Somebody look that up. Darn it, sorry. I've used this sheet for like 3 years. Never noticed it. But the point, aside from its name, and the names are kind of not very helpful anyway, clearly, is you start with, are the measurement weights different? And then you kind of skip ahead and you say, well, are the structural intercepts different? All the way up to structural intercepts. And then all the way up to measurement residuals. The point is, you don't have to test every single step. But you do test the steps in order. Did anybody look up that article?
It's strict.
Weak, strict, and strong? Or weak, strong, and strict?
Yeah, weak,
Strict.
strong, strict.
Danka. Okay. So there's a data set in that folder. Download the data set. You've used it before, but I re-put it there. And let's do this, because this is kind of awesome. Let's kind of keep this off to the side. Control Z undoes your last action?
Yeah.
Nice!
I love it.
Okay. So grab your data. Multi-group save. And let's make
We can use excuses.
I did this morning.
Single factors.
So we've got a factor, and let's just do this language variable. That's so satisfying. Are you proud? Proud but not satisfied. That's a good place to be. So did everyone do this? I'm seeing lots of glancing at the screen, so. Okay. So the question is this factor different between two groups? And let's just use this lunch variable, meaning free and reduced price lunch. So